Hola, mi clase! We are doing Unit 2, Lessons 5 through 8. I can recognize corresponding side lengths of similar triangles to determine missing side lengths. So vocabulary, we only have one vocabulary word. It's similar, so one figure is similar to another. If translations, rotations, reflections, and dilations, this is the main one. Oh, I'm not even drawing. This is the main one that causes similar figures. Can be used to fit one exactly over the other. Two figures are similar if one is a scale copy of the other. Remember, that's our scale factor that does that. All right. So fluency, this is about triangles, which even though this is review, it's important for what we're doing right now because we're using similar figures to compare triangles. So triangle JKL is a right triangle and the measure of angle J is 28. What is the measure of the other two angles? Well, we know a right triangle has to have a 90 degree. And then to find the other angle, we're going to take 180 and minus 90. That gets me 90. And then I'm going to minus 28. So I need to borrow. 10 take away 8 is 2. And then 8 take away 2 is 6. So 62 degrees and 90 degrees. All right, are these two figures similar or not? So we're still talking about similar figures here. So remember, similar figures have to have a scale factor and everything has to change by that scale factor. So does it say which one they want to go to? So we can check any of them. Remember, it's that ratio is image over pre-image. That's our scale factor. So if I count A to B, I get 3. And if I count E to F, I get 2. Okay, I can change that to 1.5 if I want to. If I check B, here I'll do another color. If I do B to C, 1, 2, 3, 4, 5. And then I need to check F to G, 1, 2, 3. If I divide that, I get 1, 2 left over, 3 goes into 20. It's like 6 times, and it's actually 6 repeating, okay? So those are not the same. And that's where that scale factor comes in. We can divide these, right? Remember, this symbol right here means division. So I just divided them, and you can see that they are not the same. So are they similar? We would say no, because they do not have a common scale factor. So we would put that, right? No common scale factor. All right. So we are going to describe a sequence of transformations that shows DEF is similar to GHI. So I do not care or worry about A, B, C, so I'm going to get rid of those. So right away, I can tell that DEF has been dilated. So for me, I would start there because I might as well make it the same size, and then I can move on from there. So I'm going to say dilate from point F. And I'm actually going to do that because the least amount of points I can move, honestly, the better. Okay, you can choose any point. You could have chosen the origin. You could have chose E. You could have chose D. I just wanted to choose F because then I only have to move D and E. Okay. So if I check, F is 1, 2, 3, 4, and the base of this is I to H, so 1, 2, 3, 4, 5, 6, 7, 8. Did I count that right? 1, 2, 3, 4, 5, 6. 1, 2, 3. Looks like I did. So it's a scale factor of 2. Okay. So I'm going to get these out of my way so I can then draw my new figure. So that means I'm going to move E and D 2 times the distance away. So E was 4 away. It now becomes 8 away. So 4, 5, 6, 7, 8. And this is where E prime goes. And then D was 4 and then 3. So it's 8 and then 1, 2, 3, 4, 5, 6 away. And so you can see I just made it larger. All right, I clearly need to reflect. So let's reflect over, make it simple, the x-axis. Okay, so if I reflect over the x-axis, E and F prime are 1 away, so they're going to become 1 away. And then D prime is 1, it's what, 7 away, so I'm going to go down here to 7 away. So here's F prime. This is what we call double prime and D double prime. And then I clearly need to translate 1 down. And so if I do that, it now then perfectly lands on IHG, which is what the question was. When we did this in our homework, the homework answer was a little different, but that's because they had a different point of dilation. And so you can see there's multiple sequences that could work. We don't all have to have the same sequence. They just have to actually show and prove that they are similar by creating FDE to land perfectly on top of IHG. All right. Problems 2 through 3. Triangle ABC has vertices located at -3, 3. B is -2, 3. C is -1, 2. Triangle A prime, B prime, C prime is the result of the dilated triangle ABC using point O, -5, 1 as a center of dilation and a scale factor of 3. First thing it tells me to do is draw triangle ABC and its image on the quarter plane. So if I go draw ABC, 1, 2, -1, 2, 3, +1, 2, 3 gets me right here. A. -2, 3, B. -1, 2. Oh, I should have put my B somewhere else. C. Here, let me fix that. That didn't look very good. Hold on. Let me fix that because my B is kind of in the way. All right. So -3, 3. -2, 3. I'll put B up here. And then -1, 2. There we go. Now my letter's out of the way. It's a little guy. Now I can't draw its image without my center of dilation. So it's at -5, 1. This is O. So to create this, we need to count distances so that we can find out how far I need to now move A, B, and C by the scale factor of 3. So let's do A first. I go 1, 2, 1, 2. So 2 times 3 is 6. So now to get A prime, I start back at O and I count 6. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Here's A prime. Okay, so if I do B, it's also 1, 2, but now it's 1, 2, 3. So 3 times 3 is 9. So count up 6, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9. B prime. And then I need to check C. So C is 1 up. Well, 1 times 3 is 3. And it's 1, 2, 3, 4. 4 times 3 is 12. So notice anytime I didn't have a number, I went and multiplied it. So I counted, multiplied, counted, and then right, I'll have to count again. So now I have my new distances. So 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. C prime. And now I can connect them. It then tells me to label my coordinates. So A prime is at 1, and then 1, 2, 3, 4, 5, 6, 7. So it's at 1, 7. B prime is at 4, and then also 7. So 4, 7. B is at 6, Nope, that's 7. See, I got to count 2. 7, and then 1, 2, 3, 4. So C prime is at 7, 4. That's how we dilate from somewhere that is not at the origin, right? I counted, multiplied, counted again. Counted, multiplied, counted again. You got to do that when it's not at 0, 0. All right, last problem. So this problem is going to be really brand new in the sense that we didn't finish the lesson, but at least it'll give you a good head start for tomorrow. So on a sunny day, a 6-foot tall person has a shadow with a length of 4 feet. Okay, so there's his shadow, 4 feet. This was like slide 4 with the length of 4 feet. At the same time, a nearby tree has a shadow of 6 feet long. What is the height of the tree? So we actually did do this in class. So we can do it the way we did in class. So I'm going to pretend I'm going this way. Since I have this information, I'm going to go this way. So I'm going to go image over pre-image. So if we do it like we did in class, I'm going to go 60 over 4. And just like in class, for time reasons, well, actually, I'll just divide it. So I'm going to go 4 into 60, just in case we don't have a calculator. So 4 goes into 6, not 2 times. I don't know where I got that from. Not 2 times. 1 time. 4. I get 2 left over. 20. I get 15. Okay, so this means my scale factor equals 15. Then I can take the height of this person, which is 6 feet, and times it by my scale factor. So I'm going to take 15 and times it by 6. So 30, 6, 7, 8, 9. And then I just found the height of the tree, which is 90. Okay, that's how we did it in class. And so I just showed you how we did it in class. Tomorrow we'll learn another way to do it so you can see how that works. All right, until next time, adios.